Would like call upon, hello, FDP team. Lakshmi? Lakshmi?
Hello. Hello.
Yeah, please. Go ahead, ma'am.
Good morning to one and all. Climate smart data-driven precision agriculture solution to increase per acre yield and reduce usage of the fertilizers and pesticides. This is the main motto of Fasal. Fasal is an AI-powered IoT platform for agricultural ecosystem that records a variety of growing conditions on farm. It then uses AI and data science to make on-farm predictions. To have more insights about Fasal, today we have Dr. Madhumita, Principal AI Research Engineer at Fasal, to deal with the topic Solving Agricultural Sector Problems by Fasal Products. Ma'am completed PhD from the University of Georgia in 2012 and have been working in the area of artificial intelligence, data analytics for over 10 years. She have been associated with several academic institutes in India and USA to work on the analytics projects pertaining to sustainability, forestry, agriculture, and many more. Ma'am also worked as lead for Hinduja Tech and helped setting up big data team of Hyundai Motor India Limited. This morning, I feel very happy to introduce you, ma'am. I welcome you to this FDP program on artificial intelligence for agriculture sector, fourth industrial revolution perspective on behalf of Indian Institute of Plantation Management, Bangalore. Hoping for a great session, ma'am. Thank you.
Thank you so much.
Thank you, Lakshmi. Thank you very much. Madam, over to you, ma'am. Session is going to be handled by you.
Okay, great. Are we waiting for someone or?
No, you just carry on. They'll come.
Okay.
40 plus they are admitted. Still people are coming.
Okay.
You just go ahead, madam. Already I made you co-host.
Okay, so can I share my screen then?
Sure, madam. Please.
Great. Okay. Okay, are you all able to see my screen?
Yes, madam. It is visible.
Okay. Okay, thank you so much. Thank you everyone and welcome to this session. It's a great honor, being part of such a wonderful session. And I strongly believe that AI is going to be the next green revolution for agriculture. And so as Sri Lakshmi mentioned that I am a principal AI research engineer at Fasal. Fasal is an agri-tech startup, and so I will be talking today a lot more about Fasal, what we do, how we do, and how we use AI to solve agriculture problems and what sector we are focusing on. So it's going to be a long session, so feel free to ask me question in between the session because I think my presentation alone will be like over an hour. So there's a good chance, what I'm saying in the beginning, you might forget at the end of the session. So feel free to ask me any question. The idea is that this should be a more of an interactive session. So I will start with a brief introduction to AI. I'm pretty sure you all might have already now been familiar in last 3 days over other sessions. But just briefly, because I would be using those terms a lot more when I talk about case studies from Fasals. So like what is AI, then types of machine learning, types of supervised learning, and how AI is being used in agriculture sector. After that, I will change gears and we'll be talking about what are the major challenges right now in agriculture. and how we can use AI to do data-driven smart farming. And because that is the idea behind Fasal. So that will bring me to, like, our next topic: what is Fasal, and how Fasal work, what do we do? And talking about Fasals, using AI at Fasal, I will divide it into two parts. One is how we use IoT sensors, and, like, what we do with that data, and what we are doing as far as remote sensing or satellite imagery is concerned. And after that, I will briefly talk about what has been Fasal's impact till now, and then the future of AI in Indian agriculture. So that's the outline of this session. And I hope we have a very good session. So let's start. So I think you have been hearing, like, what is AI? AI, it's like the science of making intelligent machines and program, sometimes, like, smart or intelligent machines and program. The definition as per is very easy and, like, sounds very simple. The problem is that, like, when the concept of smart or intelligent machine has been evolving as our technology also has been evolving. Uh, in 1985, IBM created for the first program where a machine was able to win a chess championship. At that point, that was considered very smart. But at this point, like, if we people wouldn't find that, because it's most of these games are complex rule of permutation and combination, and one can code it and make a machine do give like, win any such games. So now the concept of AI has changed a little bit. So this is the era where we are, like, focusing more on this subset of AI called machine learning or deep learning. So in AI, a human would, like, understand and identify the rules or pattern in for a given input. Then that rules are then programmed by some programmer through into the machine, and then you get your desired output. Whereas if we talk about machine learning, deep learning, then the advantage is that, like, you don't need a human being to figure out these rules. If you have enough data, you can pass on the data to the machine. The machine would be able to figure out what is the pattern or how this input is mapped to the output. And that's what we call modeling, which is nothing but a complex mathematical equation or the algorithm that we say. And then to this model, whenever you give an input, it will give you your desired output. Uh, yeah, so it will give you your desired output. So, so the recent buzz that we have been hearing in AI is actually this whole subset of machine learning and deep learning, because these algorithms are not that new. Like, they have been there for a couple of decades. But what has happened now, we have access to a lot of data due to rise in internet and also technology. Like, now we have, it's very easy to get and it's much cheaper to get powerful processors, CPUs and GPUs, where you can process this huge amount of data and run these models, these algorithms. These algorithms are pretty complex and require a lot of memory. But earlier, in 80s, when these models were developed and were being used, they were only, being used by some big academic institutes like CERN in Switzerland, or very, it was limited to only few people who could afford that kind of technology, because it needed like supercomputers. But now, I don't, like, even a small business, like, a startup like Fasal, we don't need to invest on such huge supercomputers or anything. We can simply sign up to AWS or Google Cloud or IBM Cloud, and we can rent a machine, a powerful machine there, and do these analysis. And that is why you see this huge rise in AI in this era, because now we have the technology and the resource and the data to start exploring the power of this technology. So if we talk about machine learning and deep learning, just a basic difference that usually in machine learning, suppose this is an image. If I want to use a machine learning algorithm, I will a data scientist or some data engineer would extract features from this image. Computer wouldn't understand what is this image, so you would have to figure out like this edges, this red and yellow spots, you can mark these areas. So all these features a human being will extract and then pass it on to a machine learning algorithm. So usually the machine learning algorithm, this is the input, then there will be just some complex calculation and then finally in output. And then the if you have enough data, if you're trained properly, it will be able to say that this is a diseased plant. Now, the only thing is that here a lot of human intervention is required, and then there is only a single layer, where any calculation happens. Whereas when it comes to deep learning, you don't need to do any feature extraction. You can just pass on the input of this image, not every image is actually, if you see, is a vector. It's like all these pixels. So say it's a 250 by 250 pixel, then each pixel will have some value of 0, 1 or something. So if you pass it through a deep learning model, it automatically identifies the features based on, and then you can build multiple layers. So that's the the great thing about deep learning. So they are based on this neural network. The algorithms they are used are called neural network, which is derived from how a human brain function. Though a neural network doesn't work like how our nervous system works, it's very different, but the concept is similar, that each layer pass on some information to another layer, and then it pass on to the next layer, and finally you get your output. And a lot of time goes into so this is just two layers, but some of the complex deep learning model, they have hundreds and hundreds of layers, and each layer has its own architecture depending upon what you want to identify and not. So then the great thing is it's there is very less human intervention required, and then you get your final output. And once a deep learning model is trained for for a given image, mostly these deep learning models are being used for image classification, audio classification, and NLP, natural language processing. That's where deep learning is being used. They require, they take a lot of time to train, but once trained, you can use it on similar problem also. That is what is called transfer learning. I can, if once I have prepared this kind of a neural network, I can just change the input and maybe the last two layers and feed in my images, because rest of the layers is nothing but feature extraction. So that information I can use from one model to another. So this is the difference between machine learning and deep learning. If anyone, I guess you all must be familiar by now, but if anybody has any questions, then please let me know. So next is what are the types of machine learning? A, most of the machine learning that you hear about is on this supervised learning, where you have some input and you annotate those input. These are apples, images of apple, and you annotate them as apple, and you run different these machine learning algorithms, and it maps these images to apple. So this is the input, this is the output. So once this model is ready, hello. Okay.
Please go ahead, madam.
Okay.
Some list.
Yeah. So once this model is ready, then next, if I want to, I can pass on an image of apple, and it will give me an output that it's an apple. Whereas for unsupervised learning, you don't need any data annotation. You just feed some data, and unsupervised learning is used to find pattern, if you have no idea about the data, then unsupervised is used in like, finding, clustering the data, segmenting the data, finding some sad pattern. So in this example, like if I put different fruits, then and use an unsupervised algorithm, then it will develop a model and cluster these data into similar kind of data sets. If anybody of you is like, from a background of genetic breeding, then unsupervised learning is used a lot there in this all RNA-seq microarray data, like where you have lots of genes and their expression. Then, and if you want to find some familiarity, like, cluster them on based on similarity and expression on temporal and spatial variation, then you use unsupervised learning. A lot of these nearest neighbor, k-means clustering, that is what unsupervised learning is. Um, so these are the two types of machine learning. We will be focusing on supervised learning, and this is what is mostly used. Unsupervised, as I said, it has limited usage if you want to just classify the data, but a lot of it is like, we want to find pattern, we want to match an input to the output. That's where, like, a lot of these machine learning algorithm is being used. And I will be also talking more about on like all the case studies from Fasal. I will be focusing on supervised learning only. So types of supervised learning, there is like regression. Regression is when your target, the output that you want to predict is numeric or continuous in nature. Example, like, if you want to predict, say, amount of rainfall or what is the temperature going to be for next 5 days. These are like, numerical variables that you want to predict. So that is a regression. Time series is actually a part of regression, because mostly in a time series you want to predict, suppose I want to forecast the temperature for next 5 days. The only reason I have kept it as separately, because we use time series modeling a lot. The difference is that here time becomes a variable. So for example, if I want to predict price of a crop, then like, if I'm using data, say, from 1980 to 2020, there are many variables that is affected by time, like the economy, or like, the demand in the market, or the export import trade-off. So we might not have all those features, but time kind of give us an idea that, something is changing with time. So a model will then be able to figure out that the price, that is like, as the time is increasing from 1980 to 1990 to 2000 to 2020, the prices are also varying accordingly. Either there is an increasing trend, or there is a decreasing trend, or there has been like, an increase then decrease, something like that. So time becomes an important variable, and though it's a part of regression, but the way the modeling works, it's a little bit different, because time is a variable. Suppose I want to predict the price, then last year price will have more impact in this year than, say, 10 years back price. So the way you extract feature from a time series data is little bit different. And I will be giving examples on time series when I will be talking about, like, how we do weather forecasting. The next is classification. So in classification, your target is categorical in nature, which is like, it's not continuous, it's not a number, it's some sort of two categories, or two or more categories. So for example, whether if I want to predict whether it will rain or not, my target is just yes or no. Or it could be like, yes, or like, it will rain, but light rain, or it could be like, heavy rain. So that becomes a classification problem. But if I want to predict exactly the amount of rainfall, like 5 millimeter, 4 millimeter, then that becomes a regression problem, because the output is like, numeric in nature. So these are the types of supervised learning. Once we go over the examples, case studies, it will become clearer how we are using these in agriculture. So generally speaking, where AI is being applied in agriculture, number one, like, is in agriculture robotics, though it's not being explored a lot in India. It's more in developed countries where cost of labor is high. This robotics is different from a normal, like you might see some physical robots being used in Indian agriculture also. But when we talk about AI, these are like, smart robots that are not only capable of doing some physical activity, but also of making decision. Otherwise, robotics and AI are like, different domain. There is some overlap where you have to develop a, like, smart robot. So in this image, if you see, this is like, this robot kind of is equipped with many sensors, as well as, it has like, it is also equipped with certain algorithms that it can identify, like, it scans the phenology of the plant and can identify or spot where there is a disease plant or some sort of nutrition deficiency, and then can do spot application. So these kind of robotics is where AI being applied and used. As I mentioned, not so much in India, but like, we never, like some work is still going on for India also, and in a decade or so we will be seeing more of this. The next is in agri supply chain. This is where like, AI has like, big role to play. And with the recent farm bill and like, all this going on, uh, we all are like, know that the supply chain, the agriculture supply chain in India is like still inaccessible to a lot of the farmers. They usually buy from maybe a single supplier and then sell their produce to a middleman, making marginal profit. And then there is a lot of corruption also, like, is involved, and like, they unnecessarily, like, they suffer because of this. So the whole concept of like, this using AI in supply chain is like, identifying and bringing that entire, like, the whole picture of supply chain to the farmers, so they can make the decision, and passing on that information to other consumers also, like other buyers also. Instead of like, having a single middleman and a single supplier, the farmers can have now availability to multiple suppliers, as well as their buyers of their produce. So this is one area. Then next is soil and crop monitoring and precision farming. So we at Fasal, we focus on these two, and I would be talking in detail about like, how we are using AI for these two areas. So more on that, but before I jump into that, let's just quickly go over what are the current major challenges in agriculture. So in India, a lot of our farming is still based on guesswork. It's like, traditional farming involves a lot of guesswork. Like, there is um, no, like, concrete evidence based decision making. It's more like, what the information that has been passed on to generation over generation about how to manage your farm. When to water, when to use, like, when to fertigate, or when to spray a pesticide. So it's because a lot of guesswork is involved, what is happening is like, in most of the cases, like, they end up using these resources a lot more. The in India, like, agriculture uses 70 to 90% of, like, our water resources being used by agriculture. If we talk about water use efficiency of Indian agriculture, it's on an average, it's around 38%. Whereas if you compare that with developed countries, it comes to like, they have a water use efficiency of 50 to 60%. So the reason being, like, the lack of information, the lack of right kind of resources to make this kind of decision. And the problem is that, like, this excess use of fertilizers and all that leads to, like, agriculture contributes around 20% to greenhouse gas um, to the greenhouse gas in from Indian agriculture. If you take like maybe globally, then the number will be higher. And the sad part is, like, agriculture is the most affected due to climate change. So in this year, in 2020 only, we have had multiple cyclones, flood in Assam. We had the locust attack that, like, that has happened. Everything, these incidents have happened, like, after 30 years, 40 years. Some of the cyclone is like, like that, like it happened after 150 years or 100 years. So the climate is changing. It is becoming more and more volatile. And the problem is that it's the farmers are the one who are being affected most due to it. So it's high time that we take out this guesswork, a so that it can so that we can not only cut down the contribution of agriculture into climate change, but also find ways to mitigate the effect of climate change on agriculture. So that's where I feel like AI will have a big role to play. So using AI to do data driven smart farming. um, so the idea is that instead of this guesswork, now you will use data to supplement the decision making during a crop production. And what are these data that we that could be used? One is like satellite imagery, drone technology, sensors, and GPS. These are, like some of the major sources of data that are being used to analyze and to further, like make like supplement, like the whole crop advisory, to send crop advisory to the farmer, so that they can then decide what to do, what should be the next action. And if you think of it, in this era of technology, the data is being used for all our decision making. What movies to watch, what route about, what is the shortest route to take, if you're like if you open a map. If you want to see a doctor also, like even there also, you get, like all these ratings, and based on your history, some of these apps like Practo and all, they can give you reference. If in every area, like now, if for small decisions, like where to eat, what to buy, if data is being used, then why not to use it for agriculture, which is like the bread and butter for all of us. Like that's the one that brings food to our table. So what are the benefits of smart farming? Number one is, I think, are there any questions? If you all have any questions, then please, just like ask me. I'm not sure, like if you put it on a chat, I most probably wouldn't notice. So yeah, so benefits of smart farming or precision farming is, like number one is optimizing the resource utilization. As I mentioned, that due to guesswork, a lot of this information, like a lot of the decision is not data driven. But if you use like data to identify, then that will optimize the usage of these resources. uh, so if you are like optimizing the resource utilization, it will save money for the farmers also. Then the studies have also shown, but also we have also seen in our case studies, that over utilization of these resources is not, like good for the crop health. A lot of over usage of water, irrigation, is actually a number one reason for root rot in a lot of crops. So optimizing resource utilization also leads to increase in crop yield. And uh, it will also help you in producing more export quality produce. In Because of these excessive usage of chemical fertilizers and pesticides, a lot of our produce has these chemical residues on them, and they do not meet the export quality requirement. So again, using precision farming, smart farming, or data driven, like smart farming, the farmers would be able to meet the export quality requirements, and which again is more benefit, like more income for the farmers. And finally, this way of farming is sustainable. it's sustainable to our planet, the people, as well as to the farmer. So the whole idea of this is like, you optimize your resources, so you grow more and you grow better. And that's what the tagline of Fasal is. As I think in the beginning, Lakshmi mentioned that we are an AI-based IoT, AI-powered IoT-based platform. We are focusing on horticulture crops, and the vision is that, to capture real-time farm data and bring farm specific, crop state specific, actionable crop advisory to farmers in their preferred medium and also in their preferred language. So farmers can use our mobile app using their mobile phone, or we also have a web app which they can also use through their desktop. And again, all these advisory, all this thing is available in multiple in vernacular languages. So how we do this? So we have I mean, I can divide it into two parts. One is our Fasal device, which comes equipped with many sensors that collect important farm parameters like soil temperature, soil moisture, canopy temperature, humidity, and then it's an IoT device. So using internet, it sends the data to the cloud, where it goes through a lot of our prediction engines, and then based on this data, we then send the advisory to the farmer, to the other part of our product, which is the Fasal app. So in this app, the farmer can see advisory, but also we keep sending them SMS or WhatsApp or email notifications also for important actionable items. If there is a disease alert, then we immediately shoot a email and SMS and WhatsApp message that there is a high risk of, say, powdery mildew, and what kind of spray they can use, when to spray. If there is a chance of rainfall, there is no point of spraying a pesticide. So when would be the right time to spray? So all that information, we send it to the farmers. And some of the things that we provide microclimatic forecast to the farmer. As I mentioned that with the climate change, a major impact is that the spatial and temporal variation in the weather is increasing. So if you check a weather app or anything, they usually do a forecast for maybe at a city level, or maybe a neighborhood level, a 25 by 25 or 100 by 100 kilometer grid. But that if someone can predict it will rain, say, in Delhi, but hey, is there a question for me? Okay, I don't think that's a question. Maybe I can proceed then. Okay. So.
Hello. Hello.
Yeah. Hello.
Madam, yes, good morning.
Good morning.
You told that you are giving advisory to farmers, isn't it?
Yes.
Through Fasal, you get data collected informations and give advisory what is to be done.
Yes.
So I am interested to know, actually Fasal is everywhere in all over India. Somewhere you see their vehicle is moving, somewhere there is outlet. So actually, how many
sorry, actually your voice was breaking.
Are involved in this?
Your voice was breaking, and I think there is some background.
Hello.
Hello.
Hello, am I clear? Am I clear?
Yes, yes. Now I can hear you.
Good morning. Good morning. I am Dr. Swami, ex-Dean Agricultural Engineering, Bhubaneswar.
Oh, hello, sir. Hello.
Now, everywhere we see Fasal vehicle is moving or Fasal outlet in cities. So really, how many farmers are involved all over India under
Okay.
Fasal banner?
Okay, sir. Actually, we mostly are, most of our farmers are in Maharashtra,
How
MP,
farmers? How many farmers
Yeah, I'm coming.
are
Ninkle baji away
involved
nanda.
under Fasal?
Hold on a second. Actually, I think somebody named Kishore. There is some. Please mute your mic. I think because there is. Hello, Kishore sir. Hello.
No, actually, there is some sound from somewhere.
Hello. Except Dr. Swai, can other people mute their mic? There is a lot of disturbance. Let me see if I can. Maybe I can mute them. Okay, now I think it's better. Yeah, Dr. Swai.
Yes, please. Yes.
Yes, I think your question is how many farmers do we have under Fasal's banner, right?
Yeah.
Okay. So, sir, we just to answer your question, mostly we are right now focused in Maharashtra, Karnataka, Chhattisgarh, and MP, and somewhat in Andhra Pradesh and Tamil Nadu. We have around close to 100 farmers and close to 200 plots that is under the Fasal banner, saying that we are exploring new areas and new crops also, but that is more on a research basis. We like for around for one season or two season, we collect information, we collect data, and we build all these models because all these models are very crop specific, and like as we said, it's very plot specific, crop state specific. So we collect all this information, test our models, and see that. So yeah, so we have around 100 farmers and around 200 plots. Does that answer your question?
Hello, good morning, ma'am.
Yeah, good morning.
I'm Siddharth Acharya from OUAT. Ma'am, I just want to ask a question. How do a
Right.
farmer get registered for these weather-based forecast services and all of the services that you have been provided? Is there any criteria to select a farmer, or on what basis a farmer under your banner can be selected, ma'am?
Okay, so right now we are working on grapes and tomato, capsicum, chili, pomegranate. So these are the crops that we are focused on. We are exploring now apple, mango, banana. So these are and orange also. So these are the crops that we are exploring. So if a farmer is producing any of these crops, they can visit the Fasal website, fasal.co.in, and they can we have our contact information there, so they can just call, drop an email to Fasal through any of, we are very active on LinkedIn, Twitter, Facebook, all the social media sites. So they can just contact us. And as I said, like if they fall under our crop of interest, then we definitely get in touch with those farmers.
Thank you, ma'am. Thank you, ma'am.
You're most welcome. Are there any other questions? Okay. Well, so yeah, so as I was saying that what are the things that we do at Fasal? So we provide microclimatic forecast. And the reason is that for a farmer, so if you open a weather app, it gives you the forecast, like, for the general area. So like, it might say that whether it will rain in Delhi or not. Or say if you are from Bhubaneswar, then it will say like for one particular area in Bhubaneswar, like at most you might get like whether it will rain in Acharya Vihar or Jaidev Vihar in Bhubaneswar. So, but that doesn't like, maybe that doesn't necessarily mean that it will rain equally or everywhere in that area, because a farm is like say 100, if within a kilometer you might see like, it's raining in a place, and another place that is 1 kilometer away there is no rain. So what we do is like, we downscale these weather forecast and bring it to the plot level, and we provide the microclimatic forecast to the farmers. Then we also provide precise irrigation advisory. Again, all these irrigation advisory that we provide is very, very crop specific, crop stage specific, what kind of soil they have, the topography of the farm. Based on that, we provide these irrigation advisory. We also provide very precise disease and pest alerts, as well as actionable advisory. Like if there is a disease alert, or a say powdery mildew alert, then what kind of sprays they could be used. And we make sure to like, go through the spray, that is the list of pesticides or fungicides that is approved by APIDA or other such governing bodies, that so that these chemicals and these meet the export quality requirement or are safe to be used. Then because we provide like, microclimatic forecast and up to 14-day microclimatic forecast, farmers also use our app to do crop planning for like, up to 14 days crop planning, based on like, as you all must be aware that a crop, we estimate based on the microclimatic forecast. We also estimate based on the GDD, what stage could be reached, like is it when could be the flowering, when could be the potential flowering, fruiting. So then farmers can accordingly plan. A lot of these some of the big farms might require a lot more management, and so the Fasal app can be used for that. Also, Fasal app is also being used by our customers for their finance management, their sale, their like, profit they are making, the cost of raw materials, all that can be done in the Fasal app and give you an overall overview of our finance health. So this is where what is all Fasal is being used for. And if I talk about like, so now I will be moving to like, focusing on IoT sensor part, what all data we collect using our IoT sensors and how we are using this to like, provide different advisory, what all predictions we do. So in our IoT sensors, we collect canopy temperature, we collect canopy humidity, we collect air pressure, rain gauge. We have a rain gauge that measures how much it rained. All these information we collect hourly basis. Also wind speed, leaf wetness, and as you all might be aware, like leaf wetness is a very, very important parameter for pest and disease prediction. Then we also collect like, the soil water moisture content or the soil water tension. We collected at both primary root zone as well as secondary root zone. And we also collect information on soil temperature, lux, and solar intensity. So this is like our main device that comes equipped with all sensors. We have around 5 variation of the device that like, suppose a farmer want to have one main unit, and if they have, and each Fasal device we suggest, if it's a flat land, then for a 1 hectare land, like, the device is good enough. But if somebody has the area more than 1 hectare or around 2.5 acre, then they can, suppose they want to use multiple devices, but only for irrigation advisory. Then we also have like, Fasal device that comes equipped with mostly this soil water tension, soil temperature, these information, and not so much up with like, the other like wind speed, like it doesn't come with the weather unit. So there are many variations. We have variations for the nursery, for poly houses, but the main Fasal device comes equipped with all these sensors. And we usually advise that to use the main unit along, and you can supplement it with other units for your requirement. So as I mentioned, the number one is like, we do microclimate forecast. Microclimate, if we divide, like, if we start classifying the climate of a region, then you can say the climate of a larger area or a region or a country, or like, say at most like, of a district level, that is considered macroclimate. And then you have mesoclimate, where say your plot is located. That could be, you can bring it down to further to tehsil level or block level. And most of the weather app that you see, they provide forecasting for this at mesoclimate region. Whereas microclimate is like, that depends on, as you all must be aware of, like, with the kind of crop you are growing, the kind of canopy you have, your microclimate could be changed. Like, the temperature, if you have like a shaded, if you have a tree crop, then the microclimate there could be 2 degree, 3 degrees less than the temperature, could be 2 degree, 3 degree less than what's like, outside that canopy. And for a crop, the GDD and everything is based on this microclimate. Like what stage the crop will be, when it will be, it is mostly based on this microclimate. And microclimate is like, complex interaction between like, how not only just the canopy and the structure of the crop you are growing, but also the landscape, or like, a hilly area will have this area of microclimate will be much more diverse. What side of the in a hilly area, like, the sun facing, the angle of the sun also changes if you move from like, one field to the other. Also the kind of soil you have, how like, the water loss capacity of the soil, all these kind of contribute towards microclimate. So it's a much more complex interaction. So what we do is we use a very dynamic time series modeling. As we know, due to climate change, the like, the overall, so going back, though microclimate, it can be, you can maintain the climate of within your plot, but microclimate is also affected by the meso and the macroclimate, like, the outside, like how the climate is going to be affected. Maybe the variation based, like nowadays people have this climate scientists and urban planners, they have this concept of having a climate proof, building a, like, climate change proof plot or a farm, or like, maybe a society where people can live, like, you can have landscape and building similar that, so that a lot of these variation in mesoclimate wouldn't affect your microclimate, like the sudden change in temperature, or like, the decrease in temperature or rainfall. You can still control that to a level using your microclimate. But saying that, it's like up to a certain level only you can regulate it. It's still affected by the mesoclimate. And this, due to the climate change, the overall the mesoclimate, or if we say climate of our region, of a country, is of India, or like all globally, the climate has become very volatile. Like, sometimes like we see no winter, and sometimes we see very harsh winter. So what we use is like a very dynamic time series modeling. As I mentioned, in time series modeling, time becomes a very important variable. So we take the data from our sensor and we give more weightage to the local data. We also take features from other satellite images, like how the other atmospheric parameters also, like how the ocean current are moving, how the pressure of that area looks like, coastal area looks like, what is the nearest water body, what are the things happening. So there are so many parameters that affect the temperature of a region. So we take that, but we also give more weightage to the temporal data, to the local data, the microclimatic data that we collect using our sensor. And we give more weightage to, say, past 1 week data over other data. But we also include, we take historical data to include the seasonality as well as trend. So say from 2019, how the season was, when the temperature usually was higher, lower, what was the min max temperature. So that goes into, but more weightage is given to recent data, recent local data. And then using this model, we provide hourly temperature, humidity, and pressure forecast for next 24 hours, as well as a daily forecast for next 14 days. So all this is the farmers can see in their plot. They have if they go to the plot, they have a hourly forecast as well as a daily forecast for next 14 days. Um, so because we do all these microclimate forecast, we already, so here is an example of, like, if you see, our forecast is a lot more accurate. And this is this data is for like 500 hours we just tested. And our prediction is our temperature difference is not more than 2 degrees Celsius. Like, that's like the mostly the forecast we provide, the temperature variation is within 2 degrees Celsius. Similarly, the humidity and pressure forecast also we provide is much more accurate than any external weather app for that particular plot. And because we do this forecast beforehand, we also use this data to do anomaly detection, or so anomaly is some random values. So these sensors are, at the end of the day, they are hardware. So they do misfire. And in India, we have encountered two like major regions. One, these based on the area, sometimes also how the farmers, how the device is being handled at the plot. Sometimes we get really weird data. Like, for example, here if you see these blue lines, they represent the data we got from the sensor. So like in this particular region, this was last year in one of our customers plot, suddenly the temperature went very high. And this plot was located in Bangalore, and this is around December. So it started recording not December, I think it was in June or July. But even for a rural Bangalore district, a temperature going 50 plus is like very weird, when and there was like a sudden rise in temperature. So turns out there was a problem in the Fasal, in the sensor. Because we have this forecast, we do this forecast, we are able to predict such anomalies. We also use this. In India, in a lot of our customers, a lot of these farms are located in very rural area, and there is like a lot of network issues. We see though we collect data at hourly point, and the device can store data for up to 4 5 6 hours. But if there is a network loss, then the device is able to store a certain amount of data. But in some areas we have seen like in a day you get like 3 4 hour, barely 3 4 hours of network, and then no network. And this kind of varies, this is very random. So when there is such this kind of data loss, if we have collected enough data, then we can impute or interpolate for those missing values also. So that there is not much loss to the data to the farmer, because data loss means loss in like all these crop advisory, the prediction will also. So we use this microclimate forecast also for detecting anomalies as well as imputing missing values. Next is, so in microclimate, we also do rainfall prediction. Similar to microclimate, we provide hourly rainfall forecast for next 24 hours, as well as next 14 days rainfall. So the rainfall forecast we provide as chance of in two ways. The chance of rainfall. The chance of rainfall could be no rain or low or high or medium, as well as we provide amount of rainfall. It is not being shown, but if you if somebody scrolls through, then they can see the amount of rainfall. Now for rainfall forecast, again, we use a lot more temporal information, as well as the overall rainfall is something that has become very volatile, and I think with climate change it's going to affect, you will see a lot more it's impacting a lot more to Maharashtra, Gujarat region, as well as Odisha and West Bengal, Assam, that around Bay of Bengal, you will see a lot more disturbances, lot more erratic rainfall, lot more volatility is going to increase in rainfall. So there is, the jury is still out regarding how climate change exactly is going to impact rainfall. But one thing is clear, that rainfall is going to get more erratic now. So again, for rainfall prediction also, our model is very dynamic, and we so we just 24-hour forecast, we also update every 6 hours, because suddenly it's rainfall is again a very complex way to predict. You have to see what kind of clouds are there, what is the temperature of the cloud, what is the height of the cloud, whether it's a low hanging or high hanging cloud. Sometimes we see these dark black clouds and we know it might rain, but then suddenly nothing happens, because the wind or the pressure is not enough to for that even though the precipitation amount of the cloud is high, but the overall precipitation amount in the atmosphere is not high enough for it to rain. So these are what we see is this is becoming very volatile and erratic. So what we do is though we provide forecast for next 24 hours, but we refresh this forecast every 6 hours, and we send advisory to the farmers. So at the beginning of the day, they can check at early in the 6 a.m. They can check how the chance of rainfall looks like. If there is low to medium chance of rainfall, then no need, then our crop advisory also says that do not spray or do not take any such actionables around this time. But if we refresh it again, and suppose it was 2 to 3 is okay to spray, but then suppose we refresh and then we figure out there is a high chance of rainfall at 2 to 3, then we immediately shoot a notification to the farmer that do not spray at this time, there is a high chance of rainfall, this could be the amount of rainfall. It's just not the high chance of rainfall, but the amount of rainfall. Maybe if the entire for next 2-3 hours, if the rainfall is going to be less than a millimeter, then it's okay. Your pesticides, it's not going to wash away all your pesticides. But if you get 2 millimeter or more of a rainfall, that's going to wash away most of your pesticide, and that will be a wastage of labor, resources, money for the farmer. So we take that rainfall prediction is something that is very, very crucial for most of our advisory, as well as most of our farmers. So I think that ends the rainfall prediction part. Microclimate forecast. Is there any question regarding this?
I would like call upon participant. Do you have any queries regarding this?
Yeah. Yes. Good morning. I am Dr. Vinishwi Nair from Kerala.
Hello, sir.
Can you, yeah. As you said, this climate change is the most crucial issue as far as
Right.
India's agriculture sector is concerned.
Right.
So, and you mentioned that you are using microclimatic type of prediction in
Right.
your model.
Right.
Can you explain a little bit more on how this downscaling is done? Because from the regional climate model, you have to downscale that to your particular locality, isn't it?
Okay, yeah. So downscaling is nothing but it's using all these AI and ML based models to so you take regional prediction, regional feature, like what is the temperature prediction for that region, coming from like, some say IMD or other, we use like, multiple weather sources.
Yes, yes.
And then we take all these regional data, all that they provide, like what is the temperature, what is their predicted humidity, pressure, wind speed for that particular hour and date.
Okay.
But we also see, because we have the temporal data also, right? So I have the data from the plot. Then we use this information from our sensor. So that becomes our target, and our input becomes all the temporal, suppose I want to predict temperature, then say like, all the temporal data, local data that I've collected of humidity, pressure, wind speed, as well as the data I'm getting from all these other sources. Plus, we also include some, we also include some from directly from satellite images, and explore in convert those images into numerical value, like say what is the precipitation amount of, like, of the atmosphere at this, what could be the precipitation amount of the atmosphere. These weather resources that we use multiple models. Some of the weather resources, we use the global forecasting model. Some use, some provide their features using the European models. Some use the ICON model. So we take all these features, and then our target becomes the regional, the microclimate temperature. And then based on that, we do a time series modeling. And and then we, like, test different algorithms, different models, different kind of lag, and for a different region. Like, you can see some similarity within a district, but even there also, like, so when a new customer comes, when we don't have historical data, our predictions might not be as accurate as we start collecting more data. Like, even if we have 15 to 20 days data, the prediction improves a lot.
Okay.
Does that answer your question?
So yeah, I mean, yeah. So the historical data which you refer is only for 15 days is sufficient.
So I'm saying that we use 2 years data for some plots. A Fasal at such has been a 2-year-old company. So for some plots we have like 2 years data. For some plots we have 1 year data. But we keep getting new and new customers also. So suppose if I get it from a similar nearby location in the similar district, then I take the data from a nearby plot, the plot that is nearest to that say plot. Suppose you are my customer, then I will take other plots that are nearer to your plots, and use their historical data, and then build a prediction model and provide it to you. It might not be as accurate in the beginning, but as I get more and more data from your plot, so what I'm saying is, like, within 15 days you will start seeing an improvement in the accuracy. Because now I have 15 days data from your plot, and as I said, in our model we give more weightage to the local recent data. So the model automatically, like, your data will give more weightage, and it adjusts the calculation and the output. So you will start seeing an improve in accuracy just in 15 days. But with time, like, to reach this level of accuracy, like just within 2 degrees Celsius to get a temperature, it would require at least data for a given season. Let's say 3 months, 4 months, and, like, in half a year, in 1 year, it gets more and more accurate. Saying that, it still is, like, even for new customers, on an average, we do not see variation over 2-3 degrees Celsius. But in some cases, as I said, when the temperature gets very erratic due to some changes, that we kind of miss. But with time, the model is able to figure it out and learn, and we keep training it on the new data, and it gets more and more accurate.
Okay, so that dynamic time series modeling is the application in machine learning for forecasting this microclimatic condition.
Yes, yes.
Okay, thank you, thank you.
Okay.
Ma'am, can you please look at chat box? Some people are posing question. Could you please look at chat box?
Here, okay.
It's
Examples, if
More.
Fasal predicted, if any, rainfall recently. So yeah, I mean, we do, as I said, we have around 200, close to 200 plots and we do rainfall predictions recently, and our sales team, we keep getting feedback from our sales team. So right now, as I said, the rainfall for Maharashtra is very challenging. A month back there was a lot of complaint from our customers at Maharashtra, that because we also acquired a lot of new customers, so our rainfall prediction accuracy was not so good. And especially we had a very high miss rate for these. So by miss rate, I mean that we say no rain, but then it rained. So we have for a lot of these, and these are like, mostly in Nasik area. So we have recently improved that model, and now we see like a 40 or 50% reduction in the miss rate. And now we are like, we are also working on a current model and further reduce the miss rate, as well as like, bring the accuracy we are trying. So currently the accuracy for Nasik region is around 70%. So the recent model that we launched, it was like, around, it improved the accuracy to 76%. Now currently we are working on a model, because now we have much more data from Nasik region, both from monsoon and now close to post monsoon also. So the model, like, it's looks like, from based on the data, that the accuracy level is going to be around 80 to 85%. And we keep benchmarking it with other APIs also, like, we make sure, like, say AccuWeather, SkyMet, and IMD, we use all their we keep benchmarking that our model should definitely provide a better accuracy than that. So that model is in right now in production, like, production, and in next few days the customers will have that model. For Chhattisgarh and MP, our customers are very happy. Like, the rainfall prediction is much better, like, much accurate, even for new customers, which is like, a surprising thing for us also. So as I said, the spatial and temporal variation it varies from state to state. So now I'm pretty sure, like, if we ever get into, like, Odisha region, we will face a lot more challenge than what we are facing in Maharashtra, maybe similar. Like, it will, within a district, the rainfall prediction will be very different. Forget about district, even in a tehsil also we see a lot of variation. Like, a model is more very accurate for one customer versus the other. So as we collect more information, we improve on our rainfall prediction also. Okay, I will elaborate more on optimizing resource utilization when I talk about, like, our smart irrigation as well as our pest management and all that. I will be elaborating more on optimizing resource utilization.
A question from Prem Kumar.
Okay, so this was the question, right?
Yes, ma'am.
Okay, okay. Yeah, so I think let's talk about resource utilization. So now we have done the reason I covered microclimate prediction as, like, as a first go, because a lot of our other advisory is dependent on microclimate prediction, especially rainfall prediction. It needs to be pretty accurate for us to give the right kind of advisory. So now I will be talking about pesticide and irrigation, that how we optimize and how we provide our, like, irrigation system, and how we have, like, further optimize the using water usage as well as spraying pesticide. So the Fasal smart irrigation system, we definitely, I have been saying that we provide very crop variety specific, state specific advisory. So we use the crop variety and the crop stage to figure out what is the optimum soil moisture content that is required. So depending upon the stages, like, I will be giving an example of grape, that at certain phase of the grape phenology, you need to provide deficit irrigation. It's better for the flavors and all, especially if you are producing wine variety grapes. Similarly, if we talk about like maybe apple, then when when the fruits are developing, the water needs to be, the soil moisture content needs to be high, otherwise it leads to say June drop or like the fruit drop when they are maturing. So from crop to crop, stages to stages, varieties to varieties, the soil moisture content also changes. So we use the crop variety and the crop stage to figure out what should be the optimum soil moisture content. And then we use the soil type, the data from the primary root zone soil moisture, secondary root zone soil moisture, the evapotranspiration of the crop, as well as the region, vapor pressure deficit. I think all agriculture people would would know that more than humidity, vapor pressure deficit or VPD tells more, gives a more idea about the dryness of the atmosphere. So we use VPD, as well as rainfall and microclimate forecast. So microclimate forecast helps us to we also forecast VPD and evapotranspiration based on the microclimate forecast. And we use rainfall to forecast what would be the soil moisture content. So if suppose the soil moisture content shouldn't go below 40 cb for a say a crop X at stage Y, then we forecast like how the soil moisture content is going to change. So if there is a chance of rainfall, even if it is currently at 40 cb, in an hour it will rain, and this is the amount of rainfall, and the soil moisture will again go above 40 cb. So we forecast the soil moisture content. If we see that it's there is a high chance of it going below the optimum level, then we send an advisory to the farmer that water your crops and this much volume. If they have automated irrigation, then it's pretty it's much easier to calculate, turn on your automated irrigation for say 1 hour. So we also calculate the volume, though the volume we are doing right now, it's at a testing phase. We are doing it for limited customers, but definitely we provide them the irrigation advisory, like when to water, and in some cases how much to water. So to give an example, we have been working with grapes for last 2 years, and this is the a soil water content, the irrigation advisory sort of that we follow. Again, as I said, it varies from variety to variety. This is an example for the wine grape variety that we work with. For table grapes, it could be different. So if during bud burst, the soil moisture content needs to be much higher. But when you reach say flowering stage, and when you are moving more to the maturation stage, so you move into from full irrigation to a deficit irrigation application. And post harvest, again it changes. In some regions they follow again a deficit irrigation, in some places they move to full irrigation, based on again based on the practice and the variety, what they are growing, what is the root type and all that. In this cases we we use the variety as well as the stage to figure out what is the soil water content, that is what is the optimum soil water content that is required. And then we use the other information like VPD, ET. We also forecast VPD, because if you know, VPD is just a combination of temperature and humidity, I think, yeah, and evapotranspiration, it's a lot more complex. So we also, based on the microclimate forecast, we also forecast how the ET and the VPD will be. And then every soil type, like if it's a sandy soil, if it's a clay loamy soil, the permeability of the soil is also going to be different. So like if the current soil moisture is like here, then or maybe it's over this level, then how much will it take to reach here? So that we have to send an irrigation irrigation advisory. And also, even if it's reaching here, if there is a chance of rainfall, then maybe no need to send an advisory. But if there is no chance of rainfall and it is going to drop below the optimum level, then send an advisory to the farmer. So this way, the farmers usually, if when we before we started doing it, we also spoke to farmers, and when we asked them how much you irrigate, when you irrigate, some of the farmers, they were they used to use up to 30 liters of water. If it's a tree crop, up to 30 liters of water per tree crop every 2-3 days. And then some of these vegetable farmers, they used to turn on their irrigation twice a day for an hour. That was a lot more water, especially during monsoon season. In Nasik area, the pruning and the monsoon time is when the grape is that's the grape growing period in Nasik area. And turns out they were overutilizing, they were using a lot more water than what was actually required. It's you for as you can see from this graph, you need to just maintain the water level, the soil moisture at an optimum level. So this is how we use precise irrigation, and we provide, and this is good. Over irrigating in some farmers, we saw in some of the table grape farmers also, we saw that because they over irrigate, their root length is also not that deep. Sometimes you deficit irrigation, there are research as well as we have also done some research that in some cases deficit irrigation not only save the right kind of deficit irrigation at the right time is good for the grape quality as well as the yield, and it also allows the roots to grow, make the roots stronger. Obviously drought, one impact of drought is they start storing more goes more energy into growing the roots so that it can reach out to a deeper water level. So in some table grapes, grape farmers, we saw that they have been over irrigating, didn't allow their roots to also grow. So so now we are exploring their as I said, based on the irrigation practice, this optimum level might change a little bit. Maybe for the primary root zone it could be okay, but in some cases we keep experimenting there, how dry it is it does it look like drought. So before so it's the soil water content is not only from research papers what is advised, but we also observe, our agri research team also actively involved in doing their research to figure out the right content, whether deficit irrigation is useful or not. So we spend enough time in research also to come up with the best irrigation advisory so that we can save water as well as the best yield and the quality, crop quality. Any questions here? If not, I will move to the disease prediction part. So the pest disease prediction, you all must be familiar with the triangle. There is it has to be the host, the environment, and the pathogen. They all need to be together for a disease to occur. The environmental factor that we look into is leaf wetness, temperature, humidity, and rainfall, as well as the crop stage. Because at certain stage the crops are more post pruning, a lot of these grape crops are a lot of these crops are much more susceptible to disease, especially if the environment is if it rains after pruning, then it's disastrous to these wine varieties. Some varieties of grapes, I think Bangalore brew, they are more resistant, but other varieties are very, very susceptible to disease, especially post pruning or during fruiting. So we here I'm I'm showing example of apple, because in if you would have been following in Himachal Pradesh, suddenly apple scab has become epidemic. And it's not it's after 30 years that they are seeing such an it was never an issue for last 30 years. So a lot of farmers, they are in their lifetime, they are seeing for the first time the reoccurrence and the epidemic of apple scab, because now they are getting erratic rainfall around like April, so which lead to like, the re-emergence of apple scab. That's one theory, but we are now exploring into it, like, why there is suddenly a re-emergence of scab can be predicted. The disease models that we build are very similar to the concept is very similar to a lot of this, like, Fasal model, like, their disease model, where they you look for, suppose if it's a fungus, then when the primary infection can happen, when a secondary infection can happen. If, like, primary infection happens, we send, like, preventive spray advisory. If like, if especially in monsoon, it's very difficult to get like a good window, a right window to spray pesticides. So what happens, like, the primary infection then moves to secondary infection. Then based on the rainfall prediction, we then immediately send an advisory that what can be sprayed, whether they need to do a preventive spray or whether they need to do a curative spray. And also, like, if as I said, if there is a heavy chance of heavy rainfall, then there is no point in spraying. So in that case, we try to find a window of at least 3-4 hours for the pesticides to, like, get take their effect before it rains. So we provide like a very precise spray advisory, as well as, like, much earlier detection of disease. Is there a question for me?
I would like to call upon participant. Do you have any questions? Ma'am, can you look out chart bugs? Someone, I think.
No, I don't see any internship you provide at Fasal. Yes, we do provide at, we keep looking for interns at Fasal. Please get in touch with our HR if you are looking for an internship. We are actively hiring, so keep checking our LinkedIn pages, or, like, drop an email to jobs@vocus.com, or just an email to our HR. Okay. So yeah, so our spray advisory is actually a combination of our disease and pest prediction model, as well as the microclimate forecast. Also, like, VPD is also important to consider. Like, if it's very dry, it's not advisory for to spray these pesticides, or, like, the plants can get burned, or like, there are other factors. So we look at the microclimate, or the VPD and microclimate forecast, as well as rainfall forecast, and based on the combination of this, we provide a spray advisory. Also, like, whether it needs to be a preventive or a curative spray, that kind of advisory, what kind of sprays, what kind of molecules is advisable or safe to be sprayed. A lot of like, we definitely motivate our farmers to produce more export quality produce, and it's very important to meet the APIDA requirement. If something is not in their list, we don't provide it. We don't provide that to. Okay, let me first. So image processing, I will be covering next when I move to remote sensing. That is something we are exploring. We are also exploring that sometimes farmers send us pictures for, like, whether what is this, what is this, what is the disease, something like that. Because we have some farmers at like a research basis, or at like a what we call a trial basis. So we the models, we like, we pick the major diseases, but like due to climate change, sometimes new diseases keep coming. So say we cover 80% of the disease, but 20% are not there. So sometimes farmers do get those diseases. They take an image of it and send it to our team. So right now, manually, the agri research team, they go through the image and they are looking, but we have collected enough images. We are also exploring how to make that automated, like, that they take a picture and upload it to the application. The application will give them an feedback, like what is the disease, what could be the advisory. So we are working on that, but mostly if I will be talking about in what we are right now more actively pursuing is remote sensing, and I will be talking how we use remote sensing for pathogen detection and other abiotic as well as biotic stress detection. Nasik, Solapur, Ahmedabad area removing the plots because of the increased incidence of bacterial. Okay, I think actually our bacterial blight model has been very, very effective in controlling the pomegranate for pomegranate. I have to double check like if the farmers if somebody had I think one of the case study is there in on our website where one of our pomegranate farmers, he actually was suffering a lot due to the disease occurrence. Not sure if it was bacterial blight or some other disease, but he was facing a big challenge and was thinking of giving up on pomegranate farming. But Fasal device has been very, very helpful, and they are continuing with their pomegranate farming. But about other farmers, I'm not sure. If we trying to reach to as many farmers as possible, but right now our technology, our device is maybe some not a mid-level to a high-level farmer can afford, which is you can say 20% of horticulture farmers. So we are further trying to bring, as I said, we have different variation of devices. We are trying to, which is the prices also vary because of all the sensors and all that, but we are also exploring other technology so that we can reach to most of the farmers. But if any farmer is if you are aware of any such farmer, then please ask them to get in touch with us, because our bacterial blight model has been very, very helpful in and you can visit our website and read on our YouTube channel also, you can see these case studies. We definitely have for bacterial blight, for powdery mildew, downy mildew in grapes, our models have been now, because we have now 2 years worth data, and we have tested it for more than 2 years, and it has been very effective. The accuracy is very high. Is it possible research scholars will able to work with Fasal? Again, please get in touch with our HR. I think they would be more familiar with what are available, what is not. But we have a lot of positions that we keep hiring for. If once farmer is registered under Fasal and follow all the really good number in case of our, what is the action of in case a farmer failed to get it? See, if ROI is not there, then no farmer will be our customer. So as I said, in most of the cases, all our farmers have been most of our or majority of our farmers have been trial customers. So they used our device for a season or a two, free of cost, because we also collecting a lot of information. Data is of a lot of value to us. So we and because they saw the benefit of using the Fasal, that's why they converted into a paid customer. But saying that, we have a very intense customer support system. If a farmer is not happy, if in any case they don't see a benefit of using our device, we definitely try to figure out why it is not benefiting. Sometimes in many cases we have seen it's because this is a very new technology, a lot of is misinformation how they are interpreting it. Sometimes that helps, sometimes as I said, the models are it's a new farmer, new crop, the models are not very accurate. So then we immediately in 15 every 10 days 15 days our models are very dynamic, we try to improve it so that we definitely move to meet the requirement. That's our motto. If a farmer is not making profit, then we as a company are failing, then we try to find a solution to it. Is there any consultancy services for the area Varanasi, Rewa in Madhya Pradesh? Is it free or on charge basis? So we actually upload a lot of informative videos on our YouTube channel. That's free of cost. For initial consultancy talking about our device and all, that's also I think free of cost. We definitely have in Rewa in Madhya Pradesh. I'm not sure about Varanasi in UP if right now we are exploring or not. As far as I know, we have some trial programs going on in Gujarat, in Himachal Pradesh, some in Assam, Tamil Nadu. Chhattisgarh and MP are like a major area, but UP I'm not sure. In Rajasthan, we are exploring. We haven't started yet. We are looking into Rajasthan. I think that's the all question here. So let's now move to remote sensing. So all now till now what I covered was more on like the sensor IoT sensor data that we collect. Now I will be covering more how we are using satellite imagery for the technology of remote sensing to monitor crop and again augment on our crop advisory. Remote sensing is a type of geospatial technology that samples emitted and reflected radiation from the earth in order to monitor the physical characteristics of an area without making physical contact. So that's why the name remote sensing, because you analyzing, you're collecting all this data remotely. We use what we are exploring right now are hyperspectral images. So there are like these are the satellite names, and every image data is being used, provides a different level of resolution, and like the frequency is also different, and then based on the bands, number of bands you get. So hyperspectral is like you get multiple spectral bands. So like say from visible region, like red light reflectance, green light reflectance, also near infrared region. So these are like different wavelength, and camera that you capture, like your cell phone and all, that mostly captures at the like it's just a very narrow visible range. A lot of these satellites images, they capture a much more wider range. Like even some of these use like from gamma range, gamma radiation and all that. So we are focused on like these hyperspectral images. We use Sentinel-2 data because the resolution is the best. It provides 10 by 10 meter resolution, and also you get this data every 4-5 days. And we have like data for last 3 years you for this from Sentinel-2, and it provides data from almost 13 bands, and it's being used a lot for studying vegetation. So how we use remote sensing? So what we actually use is a vegetation index. There are different kind of vegetation index. I will be talking more about it. So the idea is that a healthy plant will be reflecting like the amount of light that a healthy plant will be reflecting will be very different from a diseased, unhealthy, or a stressed plant. So there are different formulas to calculate these vegetation index. For a healthy plant, the vegetation index ranges from 0 to 1 in some cases, and in some cases it's -1 to 1. So the closer it is to 1, the healthier the plant is. The closer it is to 0 or -1, the the stressed or unhealthy the plant is. What are the different vegetation indices that we explore? This is like some of the indices that I have mentioned, but there are like around 15-20 indices that we explore. So the most commonly used vegetation index is normalized difference vegetation index. This is the formula for calculating it. So it captures like it's actually you capture the data at near infrared, what is the reflectance at the near infrared, as well as the red region of a multispectral band, and then you calculate the NDVI, and the value ranges from -1 to 1. And as I showed, the closer it is to 1, the healthier the plant is. The closer it is to 0 or -1, the unhealthier the plant is. This is a very, as I mentioned, this is a very commonly used index for monitoring crop health. It actually captures the chlorophyll content of the plant, as well as the cellular structural integrity of the plant. And so basically you can measure how like active, photosynthetically active, the biomass up crop biomasses. So you can use this index similar to study like how the crop stages is progressing, what stage your crop is, if there is any kind of stress like water stress. It has been commonly used a lot for water stress also, other abiotic and biotic stress. Though like we have seen difference in like for different disease, like other indices have been more helpful than NDVI. The other is like this soil adjusted vegetation index. This is mostly used in arid region where there are sparse vegetation. I think, as I mentioned, we are like now exploring in Gujarat and Rajasthan, so like this could be more important there. Then like the others like this green chlorophyll index. This is a very commonly used index. This is actually much better. And again, if you see the parameters, like the spectral that is being used, mostly it's like near infrared and then red region or blue region or green region from that. So yeah, so this is a very commonly used index for predicting plant diseases. And then this one here is we are exploring actually coffee plantation. So in coffee, the canopy is like the coffee plant grows in shaded, under a shaded area. So like they grow with this there will be a tree crop and then the coffee. So when there is a difference in variable canopy structure, then this index is more useful. Then so we take a combination of all these indexes. Like though I'm mentioning this has an advantage over others, but again all this is like based on a lot of ground research, that which is better than other. So based on that, we and we are actually sort of exploring a lot of these indices, like so this is the one that I have shortlisted here that we are mostly right now looking into, but there are other indices also we are looking into. So for example, this is like a say an overall image of a plot of one of our customers. So you can see like the areas that are like darkest green, that has like the highest index value, then followed by yellow and red. So most of these red are like water stressed area, like this is post a heavy rainfall, and so there you will find these waterlogged areas. You see these red reflectance. You will also find like that like water, the machine tracks, like when the machine has tracked some water, those regions also can be identified. So this is just an overall view, like so the idea is we at Fasal, we are trying to cut down the like the effort that goes from the farmer, that we can provide the monitoring, we can do the crop monitoring, as well as we can we are also, so this is for water stress, but we are also developing models to predict like disease. So this is what I think like one of, to answer your question, this is where we are using satellite image processing to identify disease, to predict disease also. So to help farmers with a much more accurate crop scouting. So if you have like a 1 acre land, to scout that area for to find like any diseased area or some kind of defect or unhealthy plants, it's still very challenging to cover that all that area by walking. Also, like if your canopy is like some like you have a tree crop, or like your canopy is more complex, then some of the disease branch could be inside the canopy, and you won't be able to explore everything and disturb a plant. So we are developing like a model that can help with crop scouting also, that we figure out where like disease crop could be, and the farmer can then in the plot, there will be a GPS to pinpoint. They can then go and remove those diseased tissue or plant, because as you must be aware that that's an important part of like managing for disease management. And so this is where we are using image processing. This is still we are exploring a lot. We have added a very initial like we are very soon going to launch a very initial version of this, and we are definitely very interested in remote sensing. because as we collect more ground data, we are exploring what all advisory we can provide to others, those who can simply subscribe for our app, and in case they don't want to invest in a Fasal device, then just using our application, what all advisory we can provide. Though the accuracy won't be as high as using if we are collecting ground data, but still what all we can provide. And so this is definitely a high area of interest. Some of the challenges are that in India, in a tropical country like India, we get a lot of cloud coverage. So usually if you get it get these data from some other APIs, like where they process this data, in monsoon season you will find no images for 15-20 days, because there is so much of cloud coverage that you don't get good quality image. So we are also exploring, we are collecting raw Sentinel-2 data, raw satellite data, and doing image processing, doing using all these deep learning models, try to as well as time series modeling, to find to take out this whole images, take out this whole limitation due to cloud coverage, so that we can get maximum amount of data at very frequent interval. Okay, so now again I will now very clearly answer how we have been saving saving the resources. So our customers, in our website you can find a much more detailed case study, but we do these case studies on a routine basis. We also keep we are on track with our customer feedback. So because our purpose is our vision is to grow more and grow better. So based on our case studies, our customers have been able, on an average, they save 20 to 30% of water. In some cases, they have save 70% of water. As I said, it varies from farmers to farmers. Some farmers have been over irrigating their plants. Some are have been doing a much better job, but still using our device, all of our customers have found that they are able to save more water. Also, there has been a reduction in spray as well as the spray cost. So most of our farmers have observed an 18 to 25% reduction in spray cost, and the maximum has been 60%. And they have also observed an increase in yield. Some of the recent studies, where I think it was due to some disease for a tomato farmer, a chili farmer, because we were able to predict the disease much earlier. Our farmers were able, their yield was much higher and of better quality than all the nearby farms. And so which was good, because they had such a higher yield and all that. So we got more customers, because then everyone was interested, how you managed to get such a good quality and good yield when there was such a major disease. I think it was for tomato, it was maybe for leaf miner, but I'm not sure. But you can visit our website and find these case studies in detail, and please go through it. It's because in India, if I talk about the future of AI in Indian agriculture, I do see a huge scope in Indian agriculture. It's high time that we start adopting this technology. But I also see this technology is very slow, that I see a slow adoption in Indian agriculture. If you see in US, the whole idea about precision farming or smart farming, it was coined in 1980. And there you will start seeing more examples where there a lot of research is going on. Farmers are actively using precision farming, whereas in India we are hearing and we are getting more and more familiar with this only in last 2 years. So we have a long way to go. And if we talk about the major limitations and what we should be focusing on, I know a lot of people ask about the affordability of the technology, but for me, I believe the major limiting factor is the learning curve. A lot of these technology and these AI, even some of the advisory that we send is also very confusing to the farmers. Like forget about the farmers, a lot of educated people also, highly educated people, AI is still a black box. And I think and I'm really thankful to, like, for this kind of session. We do need more such sessions, and so that people get more and more familiar. It's not that much like AI is no more of a black box right now. Like maybe the mathematical algorithms and all, not everybody can understand, but how the technology works, why data is important, why the accuracy improves as you collect more data, that understanding we all can have. Like that all of these technology will improve over time, how they work, why they are better than, like just a normal traditional way of farming. That is something we need to work on. And not only we at Fasal, but we as a whole, as a whole community, that is what we should definitely work on, reducing the learning curve. Second, as I mentioned, in a lot of rural areas, we have these really bad network connection. Hopefully, with this 5G and, like this advanced internet services coming, we will see an improvement in internet connectivity in rural areas, because AI definitely can help in, as I said, we are using AI for imputing this missing data, but still you need some sort, at least you need 40 to 50% of data for this imputation to be also accurate. If, like 80-90% of your data is missing, even AI is very data dependent. Thirdly, the technology, whatever technology we bring, it has to be affordable. I feel like, with innovators and entrepreneurs, this is something they need to think of. Whatever idea you come up with, whatever technology you bring in, make sure that that technology is affordable to our farmers, keeping in mind that most of our Indian farmers are, like marginal farmers. So think of, like what is the kind of technology they can afford, and come up with variations or something that can help our farmers, or have tie up with agriculture research institutes as well as government to come up with a solution that can be helpful to most of our farmers. And finally, I would say, as I keep saying, that we at Fasal think that data is of value. It's and we keep collecting these data, but it's just not us. I think we as a community, like we as a because a lot of you are in academic institute, do collect data. Like sometimes when we move into a new area, like a new completely new crop, a new research area, we rely on agriculture institutes and on their research data, on their field data. So not only collect the data, but also maintain the quality of the data, how you are storing it, like make sure the data quality and all this is good, because all these models are, again, very, very data dependent. And the accuracy will, like in future, when we have a very affordable technology and all these available, what could, like what could be a bottleneck is the data, the quality of data that we have. So we should definitely focus on collecting more data and good quality data. I think that's all from my side for this session. I let me see if there is any more questions.
Yeah, in chart box, can you look at, ma'am?
Yes, yes. So resources for crop monitoring, like data set and relevant research material. A lot of, so our research material comes, like some of the research materials comes from, like, what is already available, published data. Sometimes we collaborate with like, different agriculture institutes to get some relevant research material. But we also do our own research. As I said, we whenever we move to a new crop, a new area, we definitely have like a 1 or 2 season of a trial period where we collect information. Like before deploying, before starting this, we design an experiment, like what all factors we need to analyze, how to what sort of an experimental design it has to be, how many devices we need to deploy so that it can cover all these factors and at enough replications. And then we collect that data, we analyze that. So say for example, if we are testing, if a model that disease model we developed, how relevant it is, how well it's worked. A lot of our weather forecasting model is also tested. We are also now exploring into, like soil data, managing soil quality. So a lot of things we do it on research basis. what kind of models are better, either machine learning or deep learning models? Honestly speaking, as a as an AI research engineer, I would say that models. So if we talk about 80 to 20% effect, so models, they will take if you move from machine learning to deep learning, these, as I said, deep learning models are very powerful, but they require a large amount of data. So if you have a lot of data, then deep learning models outperform machine learning models. But for a given limited data size, you won't see much difference in a machine learning and whether you use machine learning or deep learning model. What is very important is that you select the right kind of feature, you select the right kind of data. So a lot of our effort goes into taking the right kind of data, finding the right kind of features. So I can take all our sensor data like soil intensity, solar intensity, soil moisture, everything, and just try to run a model. But if I don't have the right kind of feature, which is how much was the temperature, how many hours was this temperature, what was like the leaf wetness, like, so then if I don't have the exact right kind of feature, and no model will give you very much accuracy. So we spend a lot more, like I would say 80% of our time goes into data processing, understanding what all features are there, looking at other work, similar works that has been done, understanding the science behind it, and focusing on that. Because you can spend if you move from machine learning to deep learning models, a single deep learning model, building that model as well as training that models can take 2 to 3 days. So it's better to start with something simple, understand your data, and then move to a more complex model. Yeah, not only just the size of the data. So as I said, it's just data. You can have millions of, like, maybe you can have 1 terabyte of data, but once you start looking, pre-processing the data, most of it is garbage, not properly annotated or something. Then you end up with even less than a GB data. So it's just not the size, but the quality and the kind of data you have. So that is also important. Any other questions?
So I would like to call upon participant. Do you have any questions still?
So we have 10 more minutes. If you have any questions, then please do ask me. Any unsupervised learning models?
Hello.
Yeah.
Yes, go ahead.
Dr. Chain, Satyananda Swami Bhubaneswar.
Yeah, hello, sir.
Am I audible?
Yes, sir, you are audible. Please go ahead.
I saw your analysis of rainfall and all that. It is very nice, but sometimes it has not given correct answer. So what are your plans to make it more effective?
So as I said, sir, obviously sometimes it has, when it comes to rainfall, I believe that it's never going to be 100% accurate, especially for the way it is, we are 3/4 of our country is a peninsula, it's covered by sea, and some of something like Bay of Bengal, which is very erratic, and so it won't be 100% accurate, but saying that in the accuracy will vary from as I said, for Chhattisgarh and MP, the customers are very happy. Whereas something like Maharashtra, and if we ever explore into Odisha, Assam, there the accuracy will be more challenging. So what we are doing is coming up with better features. As I said, when it comes to cloud also, there are a lot more features, and also we are trying to cover more global. So a microclimate, a rainfall is just not dependent on what is happening around India. It is also happening suppose if monsoon leaves from India late, then the monsoon happens in Australia later. So there is a lot of
interlinked.
Exactly.
Okay.
So there is a lot of, so we are trying to now expand our modeling traveling to not just to Indian continent, but also explore data from other continent, find features, how to accommodate that in our model, and maybe come up with multiple. So we have multiple models, but like more dynamic models, and that can, like, self learn. I think you had a session on reinforcement learning. So like, incorporate more of that reinforcement learning, so the models can improve on its own. So right now, like, we need to manually intervene. Yeah, exactly. So we are exploring more.
May I know where is your institute located?
We are based
Your
in
institute.
Bangalore.
Oh, acha. Fasal is Bangalore based.
Fasal, yeah, Fasal is Bangalore based. Yeah.
Thank you, thank you. Nice to listen to so much information and very informative. Let us hope we can use it for our conditions, for our students. Now, I am also teaching agricultural engineering to BTech students.
Great, sir.
So, okay, thank you very much.
Please, we look forward to such collaborations. It's, as I said, it's very important for us also. How much reliable are the sensors, as most sensors would not be accurate? How would you deal with such cases related to hardware? So there are two ways we are dealing. One is, we definitely, we do a very, very strict quality analysis, so that, like, our sensors do not go bad. Also, we have come up with a diagnostic app. So our customers can go and they can download this app, they can go and connect it to the hardware, and it will figure out if there is anything wrong in the hardware. And as I mentioned, we also do we run AI also. We use AI to identify, like, such anomalies in the data. It's if suppose 20% of the time, or earlier the day, our sensor used to give 20% inaccurate readings, but now we have reduced it to less than 5%, because we keep tracking also where it is going bad, why it is going bad, figure out, like, what is, we keep changing our sources also.
If it is less than or around 5%, the model is wonderful. There is nothing like that.
Yes, yes. This is, like, we are very soon going to launch a version 4 of our hardware. So every version we are improving on the reliability of our sensor, as well as the usability of the sensor. Like, we want to make it more customer friendly also.
Hello.
Yeah.
Thank you very much.
Madam.
Thank you very much.
Thank you. Yeah.
Hello.
Yes. Yes, sir.
Madam, I am Dr. Mali, calling from Kolhapur, Maharashtra.
Hello, sir. Hello, sir.
Hello, ma'am. As you mentioned that artificial intelligence is, not growing much better in India, and future prospects you also see very less. I think there is one reason for that, is that we are not able to reach to the small and marginal farmers, and the technology is not affordable. That may be one of the reason. And in this regard, what Fasal is doing to make it affordable, and whether you are serving to the small and marginal farmers, especially I am interested to know in Maharashtra whether Fasal is providing the services.
Yes, actually, Karnataka and Maharashtra were one of our first, study area. If you definitely must be familiar with, like, Sula Vineyard.
Yeah.
They have been, one of our first initial customers. But saying that, so initially when I started, so why I think affordability won't be a problem. It might be like, as I mentioned, right now, maybe the entire end-to-end technology, maybe only 20% of the farmers would be able to afford. But when we started 2 years back, that number was, like, less than 5%. The cost of our device was maybe more than 4 times than what is the cost right now. So in 2 years, we have we have reduced the cost. Like it's now, it will cost you like 1/4 of what it was costing then, and without changing the without compromising with the quality of the technology. So we are working further more on making it more. And as I said, now we are capture we have around 40 to 50 customers from Maharashtra region only, if I'm not, I have to check the numbers again, because we keep growing. Like in last 24 hours only, we have 7 customers, new customers onboarded. So we are right now growing a lot, especially in Maharashtra, Chhattisgarh, MP region. So one of the reason being that the technology is now a lot more affordable to customers, and the farmers then see a benefit, like whatever, if it cost you X amount in a season, most of our customers in 1 season or 2 season, they have reaped that benefit. Like they have made so much of profit that they have gotten the price back of this technology. And and this device is good enough for next 5-6 years. So one investment, and within maybe a season or 2, you will get the benefit out of it. So yes, it is growing slow right now, but I see that in next few years you will see a much more rapid growth in this technology, because of this is a challenge. What you are saying now is a challenge for a lot, and an opportunity for a lot of entrepreneurs, a lot of our startup. If everything was available, if everything would have been perfect, then we wouldn't have survived. But as a business, we were able to, because we found the problem that there is a technology and there is this issue, and these two can solve each other. And the only thing is make it more affordable, make it reachable to reach out to all other rural farmers also. So as I said, we are doing that on our own, as well as we are always looking for partnership and collaboration with academic institutes as well as government institutes, to how to make this accessible to everyone. And we keep exploring other whatever technology is available, so that we can reach out to maybe 80%, 90% of farmers in India.
Thank you. Thank you so much.
You're most welcome.
I think you cleared all the queries, ma'am.
Okay.
Okay,
great.
ma'am. On the behalf of FDP team and IIPM, I would like to thank to you, madam. Such a wonderful session. I hope that the people who not belongs to the artificial intelligence, ML and AL, they also DL, they also learned enlightened little knowledge regarding for the how you just carry forward starting from slide 1 up to end slide. Really, it's fantastic, madam. The way how you, especially when you started first and second slide that about AL, ML and DL subsets, that figures what you shown, the diagram that indicates a more information, right? Really, that you carry forward another type, like types of supervised learning. There you talked about regression, time series and classifications. That also explained very well, madam, irrigation concepts. And also you talked about forecasting of a rain. And Fasal, how you are facing a problem, because how you are given your forecasting, it is not happening in Nagpur, especially in Maharashtra. Maybe you said it is a differ from state to state, place to place.
Yeah.
Really, it's a wonderful, madam. Even Fasal, what actually practically they have cases. You explained very well, madam. And also you talked about Fasal disease projections or projection going to be forecasted, and remote sensors. You talked about more. And also Fazil's impacts, you talked about 3 segments, like how you're going to be talked about saving the water. You just mentioned that the percentages average is 20 to 30%, the maximum it may go for 70%. Another one also spray costing, also you mentioned really that you mentioned that average 18% to 25, max it goes for 60%. And coming for yield increase, also you mentioned that average 8 to 15% and maximum 20%. Really such a wonderful information, madam. Really, it's maybe when we go for take off any research works, that also going to be, there is a scope, there is a gap we can identify to write our proposals to the national agencies. And also last slide you mentioned about the future of AI. I'm sure that, madam, I'm sure further coming years, AI going to be played a very important role in the Indian agri sector. Of course, Fasal also is one of the major partner for the development of the AI, especially in India. Thank you very much, madam. And I would like call upon FDP team. Can I have a vote of thanks?
Hello.
Yeah, please go ahead, Lakshmi.
Ma'am, your expertise in this field is very vast, ma'am, and it's my pleasure to have been asked to propose a vote of thanks on this great session. I, on behalf of Indian Institute of Plantation Management, Bangalore, and the FDP team, would like to extend my most sincere thanks to you, ma'am. And I, as a student, also learned many things, especially about the benefits of precision farming and how Fasal is doing. And hoping all our participants will make use of this session, ma'am. It was a great session. Thank you, ma'am.
Thank you so much. It was
Sure.
wonderful being part of this session.
Sure, madam. Further programs we will invite you. You just want to come as a resource person.
Sure,
I'm sure
definitely.
that.
Yeah.
Sure. Thank you, madam. Thank you very much, madam.
Thank you so much. You all have a rest of the session. I hope you all enjoy it.
Yes,
have
yes.
a good day.
Yes.
Okay.
Thank you, madam. Thank you,
Yeah.
madam.
Bye.
Bye, madam. Thank you, madam. And I just I want to inform you all the participant afternoon session is going to be our resource person, Dr. Madan Kumar Lakshmanan from CSIR Chennai. Is going to be talk about AI based near infrared spectroscopy for the analysis of food products and also agri producers. I'm sure that will also very enjoy. Is from National Institute. I would like all participants be at sharp 2 o'clock. We'll start our session, afternoon session. Thank you very much.